Hey guys, in this lesson we would understand how to differentiate or how to identify exponential, linear and quadratic functions. Let's see how the exponential function first looks like. We know exponential function, base function or the parent function is y is equal to b to the power x. Linear function we already know is y is equal to x. And quadratic function we know is y is equal to x squared. If we write it in the form of function, so it would be fx equal to b to the power x. This one would be fx equal to x. No power means power is 1. Quadratic is fx equal to x squared. Here we have to note that for exponential function, x, the independent variable, is raised as a power. For linear and quadratic function, the independent variable, that is x, is written as a base. For linear function, the power is 1. Here for quadratic function, the power is 2. But x, the independent variable, is written as base for linear and quadratic function. Whereas for exponential function, x is written as a power. We have already learned how to draw the graphs of exponential function. So if b value is greater than 1, the exponential function graph is an increasing graph or it's a growth graph. And if b value is less than 1, then it's a decreasing graph. So this is b is greater than 1. This is b is in between 0 and 1. There will always be an asymptote in this graph. When it comes to linear function, the graph is a straight line graph. When it comes to quadratic function, it's a parabola. Depending upon the equation or transformations, the parabola could vary, but it is going to represent ultimately a parabola. This one will represent a line. Line could be going through the origin or up, down, increasing or decreasing. So the general look of the graph stays the same. Here it's a line, here it's a parabola, and here it's the growth or decay kind of a graph. So if we see a graph looking something like this, we would say it's an exponential function graph. If we see a graph with a straight line, we would say it's a linear graph. And if we see a line with a parabola, we would say it's a quadratic graph. If we see the equation with base to the power of x or x is raised as a power, we call it an exponential function. If we see an equation with x to the power or the highest degree of x is 1, and it's a linear function. And if we see the equation with x as a degree of 2, it's a quadratic function. That's how we figure out the differences between exponential, linear and quadratic function using equation. So this is all equation method using graphs. So this is all graphical method. So if the question is given in the form of table just like this and they ask us to compare or find out which one is an exponential, linear or quadratic function, then what do we have to do is we find out the common differences or finite differences. So let's start with this one. But before finding the finite differences or the differences of the y values, we always make sure that we check the x side. The x should also go up by the same amount, or there should be a pattern in x as well. We see x is going up by 1s, so we are good to go to check y-axis values. We see there is a common difference of 6 minus 3 is 3, 9 minus 6 is 3, 12 minus 9 is 3, 15 minus 12 is 3. So it's basically going up by 3s. And we see that the first differences are equal. If the first differences are equal, we conclude that the function is a linear function. Let's check this one. Here also we need to make sure that the x has a pattern. So here also x is going up by 1s. We are good to go to check the y values. When we find out the differences, 1 minus 4 is negative 3. 0 minus 1 is negative 1. 1 minus 0 is 1. 4 minus 1 is 3. We see that the first differences are not equal. Then we start to check the second differences. Here we have negative 1 minus negative 3 is a 2. 1 minus negative 1 is a 2. 3 minus 1 is a 2 again. And we notice that the second differences are equal. So if the second differences are equal, that means the function is a quadratic function. Now coming to this one, if just in case first and second differences both are not equal, then what we do is we check the common ratio. And how do we check the ratios is, we do not subtract, but we divide. So if we divide 0.5 with 0.25, we would get a 2. Similarly, if we divide 1 by 0.5, we get a 2. If we divide 2 by 1, we again get a 2. If we divide 4 by 2, we again get a 2. So when the ratios are equal, then it is called exponential function. So we can conclude that if we're given a question in the form of a table and we have to figure out if it's exponential, linear or quadratic function, if the first differences are equal, it's a linear function. If the second differences are equal, it's called a quadratic function, and if the ratios are common, then it is called exponential function. And that is how we differentiate among the three functions.